Hello everyone. This is Bincy Joseph from the Department of ISC, AJIT, Mangaluru. In this session, we will discuss the last part of extendable hashing, the fifth module. Okay, here we'll discuss two alternative approaches, that is dynamic hashing and linear hashing. We already discussed about extendable hashing in our last session. Okay, now we'll see to what is dynamic hashing. Okay, functionally, this dynamic hashing and the extendable hashing, which we discussed already, is very similar. That is, both use a directory to track the addresses of the buckets, and both extend the directory through the use of tries. Okay. The difference is that in dynamic hashing, it starts with the hash function and it covers an address space of a fixed size. And when the buckets within the address space overflows, they will split, forming the leaves of a trie and grows down from the original address node. We'll see to the figure to understand this more clearly. What is this dynamic hashing? Okay, this figure shows the growth of index in dynamic hashing. Okay, you have A, B, C. That is, it shows the splitting, how it is split. Okay, here it shows A. Figure A shows initial address space of 4. That is 1, 2, 3, and 4. This is called the original address space. And you have 4 buckets which descends from this original address space. See, 1, 2, 3, 4 buckets descending from 4 original address space here. Okay, this is figure A. Okay, in figure B, you can see that at address 4, this one. Okay, this particular address overflows, that is the number of records increases, and this particular node will overflow here. Okay, in that case, what happens? It is split into two, that is 40 and 41, two address spaces. Okay, now see to this shape of this original address space. Earlier it was a square, right here. Now this is a circle. That means, see, here this was an external directory. External directory means it points to a bucket always. Okay. Now this is an internal directory. That means it has two children. It is not pointing to a bucket, but it has two children. That's why it is called internal node. Okay, and these two are the external node, that is a 40 and 41. Why? Because it points to a bucket. Each of these points to buckets, isn't it? That's why it is called external node. Okay, now see to the figure C here. Node 2 is split into 2 and becomes an internal node. Now this is the internal node represented by a circle, and it is split into 2, that is 2 0 and 2 1. These are the external nodes, so this is represented by squares. And also one more node is split here, that is no, from the previous diagram this 4 1 is going to split. Okay, Now already 4 is an internal node and you have 40 as external node, and 41 was the external node in figure B. Here 41 is going to split into 2, that is 410 and 411, 0 and 1. Okay, addition of one more bit. Now this is the 41 is the internal node and these two are the external nodes here. Okay. Okay. Now you can see that the original address space, that is in the original address space, 4 is an internal node, 40 is an external node, and 41 is an internal node, and it has two children, that is 410 and 411. 410 is an external node and 411 is also an external node. So in this dynamic hashing, to find a key, you need two hash functions. Okay. You need two hash functions. The first hash function, that is h1 of k, for example. Okay. The first hash function is to cover the original address space. This original address space. Okay. And if the directory node is an external node that points to a bucket, then search is completed. See, the first hash function, that is, you are generating a key with the h1 of k, and if that particular key points to directory 3, here 3 is an external node and it points to a bucket, the search ends here. In the other case, that is, if it is an internal node, see here you are searching using this h1 of k, it generates 2. This is an internal node, right? If it generates this particular internal node, then you need one more hash function, that is h2 of k. Okay, you need one more hash function, h2 of k, to search down the try, this one, like this. To search in this part, this is called try. You need one more hash function. If it is 4, then this is the try. You have to search through, isn't it? For that, you need one more hashing function. This is all about dynamic hashing. Okay, dynamic and extendable hashing. Comparison is that dynamic hashing uses a linked list directory, whereas external hashing uses an arrayed directory. And the difference is slower growth of directory, that is in dynamic hashing, the growth of directory is slower, whereas in extendable hashing, the directories are doubled each time. And the size of the directory node in dynamic hashing is larger than the extendable hashing. That means it gives more space, uses more space in the memory. Next we will look on to linear hashing. Okay, in linear hashing, instead of directories, here we use something called buckets. Okay, buckets are going to overflow. Okay, in the earlier ones which we discussed, that is dynamic hashing and extendable hashing, we used directory to access the bucket containing the key, right? And more than one directory there in dynamic and extendable hashing can point to the same bucket as well, isn't it? So what happens? It adds an additional layer of indirection. To avoid this additional layer of indirection, this linear hashing was introduced with the no directory concept. Okay, it was introduced by in Litwin in 1980. It is another approach to dynamic files. Dynamic means changing files, and it uses no directory. It uses what? Buckets instead of directory. When buckets overflow, what happens? Extend address space by adding new buckets in a linear fashion. See, linear sequence. Linearly, you are going to split the buckets. Okay. Bucket that overflows is not the one that is split and extended during extension of address space. This uses overflow buckets. That is, whenever bucket overflows, it is first put into the overflow bucket. If there is no that is a split in the bucket, then it will be placed in the overflow buckets, and it will continue until expansion cycle completes. And see how this linear hashing works using an diagram. Okay. See to this, you have figure A, B, C, D, E here. In figure A, this is the original address space. Here you can see that A, B, C, D. Earlier in dynamic hashing, this here we used directories, isn't it? But here in this linear hashing, you are going to use the buckets directly with the address 000110 and 11, and the bucket names are A, B, C, D, for example. Okay. Consider that the second bucket, that is B, is going to overflow. Okay, this bucket overflows. In that case, what happens is whatever extra records are there, that is the, when which resulted in overflow, those records will be kept in a overflow bucket called W here. Okay, see this W here, the extra records will be, this is called overflow bucket. Okay, but here you are going to place it in the overflow bucket W, and you have to split, right? When a bucket overflows, you have to split, right? Instead of this B, you are going to split the first bucket, that is A here. Okay, A is split to, how, where it is split? See here, it is split to capital A. Here now see the address of A, it is 000, and address of capital A, this bucket is 100. Okay, so what happened? Bucket B overflows. Overflow record is placed in an overflow bucket W, and A is split. In the next case, D split. Say this particular bucket, that is D, overflows. In that case, the extra records will be placed in overflow bucket X, and which is going to split now. After A, you are going to split B. Why? Because we are going linearly. Okay, this is linear hashing, right? You have to split the buckets linear. Okay, this B is going to split this particular bucket and form this capital B, and see to this address now 001, and the address of capital B is 00101, 3-bit address. Okay, now when this B is split into capital B, you had an overflow bucket here, isn't it, already? This records whatever was there in the overflow bucket will be placed into this particular new bucket after split now. Understood? Next, now D is a split, isn't it? Okay. Again, in the next case, there is an overflow in this D record, D bucket itself, and it is placed in the overflow bucket Y. One more overflow bucket, that is Y. Okay. Now again, which one you are going to split? Here you have split till B. Next you are going to split C. Okay, not D but C. Understood? C you are going to split. It forms one more bucket, that is capital C. And you have the address 010 3-bit address and 110 3-bit address. Okay, C, forming C here. In the next case, say this new bucket B overflows. Okay, in that case, again you have to split, isn't it? Which bucket now splits? The last bucket, that is D, is split into capital D, and 3-bit, it forms the 3-bit address, that is 0111111. Now you had two overflow buckets here, which will be placed to this particular capital D here. Okay. Now again what happens? Okay, this B is split into overflow bucket Z here, isn't it? In the next case, what you have to do, when if you want to continue, which bucket you have to split? This overflow bucket, this bucket. Okay, that is capital A you have to split here, isn't it? Okay, and this will be placed in Z, the overflow records. And after that, if C overflows, this particular again B will split, and this overflow bucket will contents will move to the split bucket there. Okay, and it continues. This is how linear hashing works. It will go on continuing like this. Hope you understood this linear hashing. Since linear hashing has the lowest storage utilization compared to other schemes which we discussed, that is dynamic hashing and extendable hashing, we can say that it is controlled splitting logic. That is, this particular linear hashing uses controlled splitting logic. That is, it includes the logic to handle overflow buckets. Okay, thank you, students. This ends the 5th module.